All right, today we're going to look at metal oxide semiconductor transistors, or MOS transistors. Shown in the picture is a lateral structure of the MOS transistor. It starts at the top with a gate electrode. Just below this, there is an oxide interface that can be silicon dioxide, but in more recent transistors is hafnium dioxide. For an NMOS transistor, there are two N+ diffusions, and there's a bulk contact. The bulk is a P- material. For a Pmos transistor, we have two P+ regions. We have an N well that's buried inside of this P- region. And finally, we have a contact to that N well. Now, the N+ and P+ regions that are lateral with the gate oxide are the drain and source regions. The transistor on the left is called an NMOS. The one on the right is called a Pmos. And this follows that the diffusion regions that form the drain and source are N-type for the NMOS and P-type for the Pmos. Now, a process that contains both NMOS and Pmos at the same time is called CMOS, or complementary metal oxide semiconductor. Next, let's look at the circuit symbols. The circuit symbols for the NMOS on the left and the Pmos on the right are shown with a conventional arrow in the direction of the primary current flow. Here, for the NMOS, we have a gate, a drain, a source, and sometimes we have a bulk contact. For the Pmos, we have a gate, a drain, a source, and the bulk contact. Now, in integrated circuits, or an integrated bulk CMOS, oftentimes the drain and source are doped exactly the same, so they could be swapped and the transistor would work exactly the same. So we adopt a slightly different symbol for bulk transistors. For the NMOS, you'll note there is no arrow, and we would note that the end terminals can be either drain or source, depending upon their potential. For the Pmos, same thing. For the Pmos, the bulk, or the N well, is held at VDD, the highest potential possible in the circuit. And for the NMOS, the bulk is held at ground. And this is to keep diodes from becoming forward biased. We have parasitic p-n junctions that could become forward biased if these connections aren't made. The drain in an NMOS is the highest voltage, and the source is the lowest voltage, if we don't otherwise have the arrow defined as above. For a Pmos, the drain is the lowest voltage, and the source is the highest voltage. Next, we'll look at the regions of operation for MOS transistors. We'll do that in the next video.